Okay, so let's find the Taylor polynomial, degree 4, for f of x equals ln of x squared centered at a equals 2. Yeah, so that Taylor polynomial degree 4, that's just T4 of x. And that just means we take the Taylor series out to n equals 4. So at n equals 0, that's just the function value at a, which in this case a is 2. So do f of 2. Then n equals 1. Well, that's the first derivative at a at 1 divided by n factorial, so that'd be 1 factorial times x minus a to the first, just it's minus 2. Whoops. Evaluating this at 2 mark. Yeah, they won't always give us 1 to evaluate at. This one's evaluated at 2. So it's f prime of 2 over 1 factorial. That's 2. All right, so then equals 2. I do the second derivative at a, which is 2, divided by 2 factorial times x minus a, which is 2 squared. 2's galore there. N equals 3. So I do third derivative at 2 divided by 3 factorial times x minus 2 to the third. And then I'm going out to n equals 4, so I got to do one more derivative. So I do the fourth derivative at 2 divided by 4 factorial times x minus 2 to the fourth. Just have to remember where to put the a's and the n's. With me there. So then it just becomes a matter of evaluating function derivatives at those individual values. All right, so if I've got f of x equals ln of x squared, my first derivative is, what would the first derivative be? Ln 1 over x squared, but by chain rule, what do I got to multiply that by? 2x, derivative the inside. And that works out to be 2 over x. Or 2 times x to the minus 1 for derivative purposes here. So then the second derivative at x would be negative 2 x to the minus 2. And then third derivative at x is 4 x to the minus 3. And then the fourth derivative at x is negative 12 x minus 4. Then it's just a matter, so now I want to do each of those at 2. So T4x here, f of 2, plug in 2, we'd have ln of 4. F prime of 2, what is that going to give me? 2 over 2, 1. 1 factorial is 1. So basically that's just going to be x minus 2. We'll clean them up in just a second. Second derivative at 2, well, that'd be negative 2 over x squared. So at 2, that'd be negative 2 over 4, 1 half, negative 1 half. 2 factorial is 2 times x minus 2 squared. Third derivative at 2, well, that's 4 over x cubed. So third derivative at 2, so I should be writing this down. Third derivative at 2 would be 4 over 8. Oh, it's also a half. Positive half, though. 3 factorial, 3 times 2 times 1, that's 6. So x minus 2 cubed. Fourth derivative at 2, that's negative 12 over x to the fourth. So the fourth derivative at 2 would be negative 12 over 16, which is 3/4. That's negative 3/4. 4 factorial, 4, 3, 2, 1 is 24. That's x minus 4. And then just, yeah, just clean it up a little bit. ln of 4 plus, that'd just be x minus 2. Was that minus 1/4? times x minus 2 squared. That'll be 1/12, x minus 2 cubed. And let's see, minus 3/4 divided by 24 is times 1/24. 1 to 8 times, that's negative 1/32. X minus 2 is T4x. Does that sound about right? That's what I got at some point earlier. So sounds pretty good. But let's also let's graph those two. Just see what we got. So let's graph F and T4 here. Work here maybe. Okay, ln of x squared. That's fun. All right, then we've got T4, ln4 plus x minus 2 minus 1/4 x minus 2 squared plus 1/12 x minus 2 cubed minus 1/32 x minus 2 to the 4th. Now let me see. Yeah, so ln of x squared kind of does that. Then T4 comes in, and it does something like this, and then just kind of drops off all of a sudden about 1, 2, 3, about at 3 there. So yeah, it does a nice job around round 2, doesn't it? It's coinciding or matching up pretty good around x equals 2, because that's what we're centered on. All right, good on that? All right, so let's do this one. Here's what I want to do with this, another step, if you will. All right, so let's approximate the integral. 0 to 1, x squared cosine x squared dx, which again, it may be doable in parts, I don't know. But that's not what we're going to do. We're going to approximate it. And let's use a Taylor polynomial. With 3 non-zero terms. 3 non-zero terms. Okay, so here we have an option. A while ago we were doing Taylor polynomials, and we were just writing them out. But let's think about this one. Since I'm talking about 0 to 1, that's technically the centers at a half, but that's pretty close to 0, isn't it? Well, why don't I use, since it's close to 0, let's just use the Maclaurin series for cosine. Cosine of x, what is the Maclaurin series? It's summation n equals 0 to infinity negative 1 to the n x to the 2, x to the 2n over 2n factorial. Well, so x squared, cosine of x squared, Maclaurin series would be x squared times summation n equals 0 to infinity negative 1 to the n. So I've got x squared instead of x, so that'd be x squared to the 2n, so that'd be x to the 4n over 2n factorial. You with me there? Whoops, times x squared. So that times the x squared would mean it's summation n equals 0 to infinity negative 1 to the n, x to the 4n plus 2 over 2n factorial. Well, that would be the Maclaurin series for that. And since I'm centered at around 0, let's just use that. I just want, it says, use a Taylor polynomial. Shoot. Let's cancel that, because I've got a little note on that in just a second. Let's just call it a Taylor series with 3 non-zero terms. But since it's centered at 0, we can use this Maclaurin series, okay? Let's not call it a Taylor polynomial. Well, since I said 3 non-zero terms, we'd probably be okay with it, but I'll mix it up. Okay, anyway, let's see. So, this integral, I can write it approximately. So if I do the first 3 terms, non-zero terms, I think. Let's write these terms out. So that'd be 1x to the second over 0 factorial, so that's 1. Then the second term would be n equals 1, so that'd be negative 1 times x to the 6th over 2 factorial. And then the third term would be negative 1 squared, so that'd be positive 1 again. N equals 2, so that'd be 8 plus 2, that'd be x to the 10th over 4 factorial. That'd be the first, that's what I was wanting us to use, those first 3 terms. So it just gives us, what that does is that just gives us a quicker route to the, I think it was quicker, quicker route to the polynomial here, first 3 terms. So this integral is approximately then 0 to 1 of that, which would be x squared minus x to the 6th over 2 plus x to the 10th over 4 factorial is 24. So that's a way we could approximate this. Instead of doing this integral, I can approximate it with this, which is integral-wise would be 1/3 x cubed minus 1/2 times 1/7 x to the 7th plus 1/24 be 1/11 x to the 11th. And then I'm going to go 0 to 1, which is not going to be that bad. Plug in the 1, you got 1/3. Plug in here, you got 1/14. right, 114. And then, 264. 1 over 264. By plugging the ones and then plugging the zeros, you got zeros. So, approximately this integral is whatever that is. One third minus 1/14 plus 0.265 6.926 blah blah blah. Approximately that. From other sources, I get that this integral is actually equal to 0.265601. 265,601. So it's good. What's good on the first 4 digits anyway. So just using 3 terms, that's pretty good. Pretty good little approximation there. So it's another source, another application, if you will, right there. Is that okay? Good with that? All right.